This is binomial. So like we said, this is a binomial experiment. Part A, I think a lot of you guys just use this formula without even thinking about, like, used it based on common sense. They're saying, okay, out of 10 shots, how many do you expect to make? Well, he has 10, that's your N, and he makes 45.4% of them. So I'm going to multiply that 10 by 0.45, and that gives me 4.54. So on average, it's like an average, right? You know, like you can have an average value be a number you can't actually attain, right? You can't actually make 4.5 threes, but on average, you would make 4.54 out of the 10. Okay. Then in part B, we want to know, okay, so first of all, I should define what X is. I'm going to say let X be the number of shots made out of 10. And I'm going to show you guys as well. You do have to recognize this notation. There is, if I write this, that notation, a little X with the squiggle, that is a fancy math way of writing X is a binomial distribution. The B means binomial. This means distributed as. So our variable is distributed as a binomial distribution. And what's important in a binomial distribution? N, the number of trials, and P, the probability of success. So you don't really have to, because I didn't tell you this is binomial, this would count as showing work on a test, right? Even if you did the rest wrong, if you told me, oh, hey, X is a binomial distribution, you can write it out in words too if you want it. This is a lot nicer. So if I know X is a binomial distribution with 10 trials and a 40.4% chance of success, I could usually give you a mark for that. It's good communication in math. You guys see, I know you never use that little squiggly symbol. That means its distribution is binomial. And you'll see it printed on exams sometimes too, stuff like that. Like they'll tell you, oh, X is binomial in this fashion. And other special distributions too, instead of writing B in there, I'll write some of the other symbols for other special distributions we're going to look at. Okay. Sorry, that was a bit of a tangent, but it's a worthwhile one to make. Okay. B, now this is where it gets good. What is the probability that he makes exactly 6 shots? And we have a formula for this. This formula, I'm going to highlight it in purple. That's a formula that tells you the probability of having a certain number of successes, right? Where K is the number of successes. So if we plug into that formula, it's 10, the number of trials, choose 6, the number of successes. Remember on paper 1, you have to remember how to do these by hand, these 10, choose 6, right? There's a formula in your formula booklet for them. Or you could draw 11 rows of Pascal's triangle here, and that would be long, but you could do it. Or on your calculator, there's a quick way to do it. I can review with you in a moment. Times P times 1 minus that. Right, this is a formula. This should tell you. And it looks like, according to the group at the back, it's okay. Now here's where it gets even spicier. Okay, we're going to do part C. What they're asking for in part C is what's the probability that he makes fewer than 6 shots? So that means I can make up to 5 shots. I could make 0. Steph Curry could make 1, 2, 3, 4, or 5. All right? So how would I do that? By hand. I'll show you a better way. But if I was working by hand.
You just have to do the same thing. They used it there for 5, 4, 3, 2.
Yeah, because remember, I could make no shots, or means add, or I could make 1, or 2, or 3, or 4. Do you guys want to do this? No, you do not. I'm gonna, hold on, let me put in a new page here. Okay, I'm just gonna do this one. Okay. So, I don't want to do that either. That's me subbing into that formula 6 times, adding up those together. Not only is it tedious, it's also very error prone. Okay? So I'm going to show you something on your calculator. Okay? Let me put this on the screen here. This is if you have your calculator, take it out and follow along. I'll share my calculator screen. Just give me 1 second. I'm going to stop presenting on my iPad. Window. Okay. So here is the calculator screen. You guys, yes, you guys can see it. Okay. So there is a new section of the calculator menus, which we're going to use quite a bit over the next week or two. So if you go second vars, there's a little menu, a blue menu called distribution, D-I-S-T-R. That's where we're going to find everything related to the special probability distributions we're going to be studying. So I'm going to hit second vars. And this is a list of all kinds of special distribution functions that your calculator has built into it. Some of these we'll use later. For now, we're going to scroll down, like options A and B. There's 2 of them. There's binom. Binom stands for binomial distribution. There's one called binompdf, and there's one for binomcdf. Now, what binompdf does, that does what we did in question B. That gives you, in a binomial distribution, the probability of having some exact number of successes. So in part B, we wanted the probability of having exactly 6 successes. Let's check our answer, see if we got the same thing, okay? I'm going to hit binompdf. And then a nice little menu pops up, and it tells you everything, it asks you everything you might want to give it about a binomial distribution. So, for instance, we have 10 trials. Probability of success in each trial is 0.454. And we wanted to know the probability of having exactly 6 successes. Okay, so that's what we're doing. And then when you're ready, you hit paste and enter. And that's what we got. So that was probably easier than using the formula, I would say. This is totally legal on paper 2s. You still have to know the formula for paper 1, right? But paper 2, you don't have to you don't have to write I used binompdf. You don't have to write I used my GDC. You can just copy down the answer. Okay, very simple. And is this clear to everyone so far? So you really need to be practicing this on your calculator. So if you don't have it, you need to question your life choices. Okay, so we're going to keep scrolling down. No offense to anyone here. The other option is even better. It's way more useful even than binompdf. This is binomcdf. C stands for cumulative, which means like I'm adding up a bunch. So this function literally does what we're asking in part C. It gives you the probability of having less than or equal to some number of successes. So I'm going to click binomcdf. And the menu, it looks identical. We still have 10 trials. Still have a probability of success, 0.454. Oop, that's not right. Let me just delete 0.454. And here we're going to put in 5 for x value. So what this function does in your calculator is it adds up all the probabilities from 0 up until what you put in as your x value. So don't put 6 here if you don't want to include 6. It's going to include in its calculation whatever you put here. Okay, so I'm going to put 5, paste it, Bob's your uncle, there it is.